Okay, so once again, here's video presentation comparing the different mapping techniques in cache or cache mapping techniques. So in the previous presentation, I give a brief description and at the same time how to map direct, associative, and set associative mapping. Now, given this example, let's say this example was given onto your module, so please do take note to study that on your own. But anyway, I'll discuss this one for you to better understand. So consider a main memory consisting of 4K blocks, a cache consisting of 1 to 8 blocks, and a block size of 16 word. Please do take note that 16 word is equivalent to 32 byte. Okay? And the given are in terms of blocks. Because there are sometimes the given is the memory size, the cache size, and the block size. Anyway, the block size is already in computer unit, not in blocks. So, there are times na ang mga given po natin, instead na 4K blocks, ang binibigay po nila is 4 MB, 32 bytes, 128 bytes, and so on, instead of blocks. See the difference between blocks and bytes. Anyway, I'll give an example of this one later on for you to understand. Anyway, ito kasi binigay na to is diretso na po siya as blocks. So, in direct mapping, our memory unit address or main memory address, MMA. So, main memory address is subdivided into 3. Sir, ano po ba yung main memory address? Okay. To explain it to you, di ba ang ginagawa po kasi natin, pag nag-click po tayo ng command or sabihin natin press natin yung mouse, if we press the mouse or if we click the mouse, if we press the keyboard, ang ibig sabihin po kasi nun, nagsisend po tayo ng command or pag nag-open tayo ng file, nag-execute po tayo ng mga command. So, ang ginagawa po kasi natin, ang ginagawa po ni computer po natin, dun sa mga commands po na yon, take note, dun sa mga commands na yon and information na yon, sinisave niya po sa main memory or sa RAM. Imagine pag nag-open ka ng Microsoft Word. Ang gagawin ngayon ni computer, i-save niya sa RAM yung inopen mo na Microsoft Word. Now, di ba nakasave sa RAM ngayon yung Microsoft Word mo? So, para mas mapabilis, pag lagi mo naman ginagamit yung Microsoft Word, lagi kang nag-open ng mga files, mga documents, so lagi mong na-open yung Microsoft Word. Ngayon, ang gagawin ni computer natin, isi-save niya yung Microsoft Word sa cache natin. Or, definitely, isi-save niya some parts of Microsoft Word into our cache para mas mapabilis. Para pag i-access natin ulit yung Microsoft Word, mas mabilis na siya compared to the previous one. Ngayon, yung main memory address po natin, yan po yung address, take note yan po yung address na pinanggalingan ng information na sinave natin sa cache. Okay? In direct mapping po kasi, take note, in direct mapping, just to give you an example of, just to recap our discussion last time. Okay? In direct mapping, imagine we have our main memory or our RAM. Then we have cache. Main memory and cache. Now, imagine ito na may data A, B, C, D. Of course, this one, may mga address po yan. May mga addresses po yan. Kasi nakasave siya sa memory. So, A, B, C. Ngayon, Ang ginagawa po kasi natin sa direct mapping, sinisave po natin ito into cache blocks. So this is cache. So save po natin si A. And then, si B saan natin ilalagay? Si C saan natin ilalagay? Si D saan natin ilalagay? As you all know, in direct mapping, many to one po kasi siya. So meaning, a single block cache. Cache block. A single cache block. Okay? A single cache block is pinagsasaban po or pinaglalagyan ng maraming data from main memory block. Kumbaga, di ba yung formula natin kasi last time is J is equal to I mod N. Okay? Diyan natin ma-determine kung saan natin ilalagay yung data natin. So, si A, ilalagay natin sa cache block 0, si B sa cache block 1. Okay? So, dito, si A, dito si B, dito si C, and dito si D. As you can see, si A and C, pwede malagay siya sa A. Tama? Pwedeng malagay siya sa cache block 0. So, si B and D, pwedeng malagay sa cache block 1. Now, for our computer to monitor kung anong data yung nakalagay doon, kasi sa cache block 0, possible na si A or si C ang nandun. Now, for our computer to track that one, kung anong data ang nakalagay doon sa cache block po natin, sinasubdivide niya yung main memory address into 3, which is word field, cache block field, and at the same time, we have tag field. So these three are to make up our main memory address. Now, to determine the word field po natin, that is word field is equal to log of B in the base of 2. Word B is our block in words. So, kumbaga, eto po yun. Eto si B. Now, so that is actually, para mas mapabilis po, para hindi na po kayo gumamit ng calculator ng log 2, log 2, and so on, ang gawin nyo lang po, etong 16 na to, you convert that one into powers of 2. So, 16 is actually 2 raised to 4. Okay? Now, that is actually 2 raised to word field. So, now, our word field is equivalent to 4. For the cache block field, so cache block field, that is equivalent nagre-record. So, cache block field is now equivalent to log of cache blocks in the base of 2. Asan po yung cache blocks po natin? Ito, 128 blocks. 128 blocks. So, you convert 128 into powers of 2. So, that is actually 2 raised to 0, 1, 2, 4, 8, 16, 32, 64, 128 raised to 8. Or that is actually 2 raised to cache block field. So, cache block field is now equal to 8. Next, we have we have the tag field. Our tag field that is actually log, take note, log of main memory size, main memory block all over cache blocks. Cache blocks in the base of 2. So that is actually anong main memory blocks natin? 4K all over 128. Right. So that is 4K divided by 128. So calculator lang tayo. 40, 96. This is actually 4K. I-kwan ko na lang into powers of 2 para mas kwan. Hindi na tayo mag-calculator. 2 raised to 8 ba ang 128? No. Sorry. This one, cache block field is not actually 8. It should be 7 pala yan. So, 2 raised to 7. So, this should be 7. So, 7. Now, so of course, 128 is equivalent to 4K, that is 2 raised to 2 times 2 raised to 10 all over, this is log of 2. 2 raised to 7. That is actually log of 2, 7, 2 raised to 5. So our tag field is now equal to 5. Okay? Ito exponent rule lang po yan. So 2 raised to 2 times 2 raised to 10, that is actually 2 raised to 12. 2 raised to 7 divided by 2 raised to 7, so that is 12 minus 7, kaya po siya naging 2 raised to 5. Now, our tag field is equal to 5. So, ganun lang po siya. Okay? Ganun lang po siya. Next, sa associative mapping naman po, so in mapping associative or fully associative, isa lang po yun. So, associative or fully associative. Now, in associative mapping, there are only two, or the main memory address is subdivided into two. That is the word field and the tag field. So, word field and tag field. Okay? So, the same formula pa rin po tayo. So, word field, that is same formula pa rin po tayo. Sa word field po natin, that is actually word field is equal to log of B, log 2 of B, or that is actually log 2 of, ano yung B po natin? That is size or block size. So, 16. Or that is word field is equal to log 2 of 2 raised to 4. So, cancelled. Cancelled. So, word field is equal to 4. Okay? Next. So, tag field. Tag field. In our direct mapping, the tag field that is actually main memory blocks all over cache block po natin. But the tag field in associative mapping, that is log2 of main memory blocks. And so our main memory block, that is log2 of main memory block, is 4K. So that is actually log 2 of 2 raised to 2 and 2 raised to 10. So that is log 2 of 2 raised to 12. So our tag field is equivalent to 12. Okay? Next, we have set associative mapping. Set associative mapping. Set associative is defined by K way, where K is the number of sets. Okay? Ang ginagawa po kasi natin sa set associative, direct mapping po siya. Direct mapping. But the cache blocks is subdivided into sets. Direct mapping pa rin siya, pero the cache block is subdivided into sets. Parang ganito po siya. So we have our main memory. Then, 1, 2, 3, 4. Dagdagan na lang natin, gawin natin 8. So this is our main memory. And then we have our cache. Okay? So imagine a cache with 4 blocks and a main memory of 8 blocks. So 4 blocks ito. When we say set associative, so the blocks of our main memory will be mapped into our 4 blocks. But take note, you need to create sets first into our cache block. So pag sinabi nating two-way, so yung mga block po natin, i-group mo by 2. So parang magiging ganito po siya. Ayan. So dalawang blocks lang po siya. Pero sa loob niya po yan, it is subdivided actually into 2. So, ito, block 1, ito, block 0, and then block 1. So, depending on the number of K. Now, if we are to use four-way associative, four-way set associative, in our example, so imagine a four-way set associative. Okay? Four-way set associative. Now, in set associative, our main memory address is subdivided into 3. That is the word field, the set field, and still we have the tag field. Okay. So still word field, the same pa rin po yan. Word field, that is 2 raised to 4. Kasi 16 po yan. So our word field is still equal to 4. For our set field, that is dependent into our K-way, sabi ko nga sa inyo. So kung ilang number of sets po siya. Ilang sets. So how do we determine if how many sets do we have? So set field is actually log of 2 divided by log of 2 of cache blocks all over K-way po natin, or K. So that is log 2 of cash block po natin is 128 all over 4. So, that is log 2 of 32. Or that is equivalent to 2 raised to 5. Then our set field is equal to 5. Then we have the tag field. Tag field is actually log 2 of main memory block all over let's say S. Right? Wherein S is equivalent to cache blocks. Take note, cache blocks all over block per set. 'Di ba? Ginawa natin yung ginawa nating k-way or k-way set associative or 4-way set associative. Okay? Ginawa nating 4-way set associative. So, ibig sabihin, block per sets po natin is 4. And our cache block is equivalent to 128. So, this is actually the number of sets. Okay? So, equals log 2 of main memory block. Ano yung main memory block natin? That is 4K all over 32. Or, that is log 2 of 2 raised to 12 all over 2 raised to 5. Or, that is log 2 of 2 raised to 7. Or our tag field is equivalent to 7. And that's it. So for the next video presentation, I'll be discussing about replacement techniques. Actually, I will be discussing 2 replacement techniques lang. Hindi na yung random. Kasi from the word random, it's randomized. So, ang i-discuss ko po sa replacement techniques is actually the FIFO and the LRU or least recently used or last recently used. So LRU and FIFO. And that's all. Thank you.